Good morning, everybody. Welcome to the last science seminar of our semester here. And we say the last for best. Okay, so it should be an exciting one. Okay, we have today Chris Dorr, who's coming to us from Mint Innovation. Okay, he's going to tell us about electronic recycling of material. How many EEs out there? Volunteers? No? Any engineers out there? All right. All right. Yeah. So yeah, this is an exciting thing. It's a big deal for Longview. This new facility coming into play. There's been lots of questions about the science and technology that goes with it. And Chris is here to tell us all about that today. Okay. And we at LeTourneau are glad to host talks like this that tell us about what's happening in our community. And yeah, very good. So Chris comes to us from Texas. He's a native Texan. He lost his way for a while to other places, but then eventually he found his way back to Texas. He graduated from Lubbock Christian University, and his wife is from, what was it?
She's here, Texas, yeah.
Yeah, but
Oh, Texas Tech.
Texas Tech, yeah. So out there in Lubbock as well.
Yeah.
So yeah, so all kinds of good stuff. And he's worked many years in different recycling situations here. So this is the time to think about these things because as we move and transition our energy resources, these different metals become more important to us. And you can't just always get them when you want them. So you might have to recycle, repurpose, and reuse these different things. That's going to become more a bigger part of your career as you guys develop it here in the future. So let's give Chris a warm welcome.
Yeah, thank you. Thank you for having me. I really appreciate the opportunity to talk about Mint and yeah, what we're going to be doing here in Longview. As I'm sure most of you know, at Mint Innovation, we're building our first U.S. facility here in the city of Longview. We're headquartered in Auckland, New Zealand right now, and our first commercial operation is based in Sydney, Australia. So kind of taking everything we've done over there and building the first U.S. plant here in Longview with probably several others to follow across the U.S. So why is, Mint taking this on, right? So as it was mentioned, critical metals are becoming a really hot topic. So we want to accelerate that supply chain for circular green metals. Taking metals, recovering them from circuit boards, and putting them back into that supply chain to whether they can be used in remaking the circuit boards or to go in the gold to go into making jewelry, things like that. So did make it work. So we're accelerating that supply chain. Yeah. Oh, yeah. Yeah, it is. Perfect. Yeah. So we need these critical metals. As you've probably seen on the news a lot, the current administration is really making this a big topic to keep these materials and metals onshore. So this is what Mint does. We keep it here. That's why we're building a facility here. So anything that can be recycled, we can bring it in, recover those metals, and put it back into that supply chain domestically. So we're not having to send that offshore anywhere else. Mining is no longer really a viable option. It's too capital intense. It's too energy intense. Mint is building a sustainable facility, a small scale that can be moved and modified in various regions across the world. So why e-waste? Well, it's one of the fastest growing waste streams out there. So we're looking at 68 million tons of e-waste being produced globally, right? And that's based on 2022 numbers, and it's only increasing. So globally, we're only capturing about 22% of that. In the US, it's considerably less. It's probably around 15%. So we want to be a solution in not only recovering metals, but helping collect it, right? If there's more options to process it domestically, we will collect more of it domestically. Smelting today is traditionally how a lot of these metals are recovered, and it's really energy intense, right? It's uses about 4% of the world's energy and produces about 7% of the global greenhouse gases out there. Sure. Yeah. Okay. So mentioning Mint, right? Founded in 2016 in Auckland, New Zealand. That's where our research and development facility is. This is where they brainstormed this technology that we're using, this kind of biotechnology we're using today. We had the pilot plant there, where then we went to Sydney and scaled that up. So Sydney facility processing just over 6 million pounds of circuit boards annually. So we're capturing 2 million pounds of copper annually, as well as 1,100 pounds of gold. So we have formed a partnership with the U.S. Department of State with the Mineral Security Partnership Project. So that allows us to work with other countries who see this technology as a viable solution for their challenges that they see. So as you can see here, we've got the circuit boards here, and then we put them through we take a whole circuit board, we put it through a shred and sample process. So what that does is, as it's shredding, the sampler is grabbing pieces throughout, just every 10 seconds or so, it's just grabbing a little piece. That gives us random sampling so we can take assays. So we know what kind of values there are. We're looking at the values of gold, copper, silver, and palladium. Those are the main four. There's about 16 metals in total inside of a circuit board. So it could be other metals like 10. There's going to be a small amount of rare earth metals, as tungstens and some other base type metals, aluminums, ferrous metals, things like that. So once we shred them down and sample it, we then put it through a double hammer mill. So this is a process where we're getting it down to a powder. It's a wet process. So you can see how it's a dark color. So it's been through that wet grinding process to get it to what we need for it to maximize the surface area for the biotechnology to work on it. All right, so the first process, we're taking a base metal solution and extracting the non-copper base metals from it. So, and that generates a little bit of wastewater that we're able to clean and discharge and reuse most of it. And then what we're left with is a base metal hydroxide and gypsum. So this can be used back into the fertilizing manufacturing. So it's got some zinc in it. It's got some magnesium as well. So it can be used in a couple of different areas. And then the second base metal solution we use is attacks the copper. So that copper then goes through an electrowinning process to where we're creating pure sheets of copper, right? So when we say pure sheets of copper, that's 99.99% copper. That can be used directly into the manufacturing. It does not need to go through any sort of refining process, does not have to leave the US to do that. It can literally just go right back into a new circuit board, a new motor, just name a copper use for it, and it can go back into it. All right, gold. So for the gold we use what we call a bioabsorption technique. And so we have a naturally occurring biomass that acts as a sponge for the gold. So the gold will attach itself to that. Once that process is complete, we then heat it up a little bit to where we turn it into a gold ash. That gold ash can then be turned into a coin, a gold bar, something like that, right? And again, that's at 99.99% purity. So that's going back into the manufacturing process, whether it's circuit boards, whether it's jewelry. It has a number of uses for it. So it does not have to go through any refining after that. And then as you can see here by these two charts, the advantage of mint over some of the current processes here, right? Lower on carbon, lower on energy in comparison to your traditional smelting and your mining that's going on. So this is a hydro process. So yeah, so we're using some various naturally occurring materials that yeah, I mean, keep us from having to use any sort of the nasty acids and things like that that people normally use when it comes to a hydro process. So ours is a little bit different. So enhancing local communities and economies, right? We're able to create sustainable jobs, right? So, you know, most of you in this classroom here, you know, we have a ton of engineers in New Zealand, right? So all they're doing is researching and developing how they can make this process better. How can we capture more metals? And so we rely on you guys to help us figure that out, right? So whether it's coming to work for us full time, internships, etc., we're trying to create as many sustainable jobs as we can. You know, economic impact, right? We're creating critical and strategic metals that are needed for whether it's military use, whether it's, you know, just from a supply chain for manufacturing, you know, community engagement, right? We want to partner with the local communities to collect electronics, right? Not just process a piece of it. We want to be able to collect it, process it, and then return it, right? So kind of do the full circle of it all. And then, yeah, just strengthening the recycle capabilities, right? Increasing the recycling rates is a big key to that. So as I mentioned earlier, our Longview facility is opening in 2026. So we'll start, hopefully we'll start building. We have a building already. We'll start putting pieces in, you know, later this year with an opening of hopefully end of Q1, Q2 of next year. So that's going to process just under 9 million pounds of printed circuit boards. We'll recover 2 million pounds of copper and then 1,100 pounds of gold from that facility. So as I mentioned, we have the Sydney facility that's fully commercialized. Everything we've kind of learned from that first plant is all going into the second plant. So we'll have additional process to make sure we're creating the purest product we can. So we can skip a few steps and go direct to the supply chain for it. So let me show you the video here is our Sydney plant. So you can see there a lot of tanks holding material, as well as this is the beginning process here where it's going up through the double hammer mill, and then yeah, all the piping, the liquids pushing things every different direction. And so we process, and Longview will process about 5,000 pounds at a time. And so we'll be able to do probably 4 batches a day of that. So a lot of things come out besides the copper, with copper going through the electrowinning process. Everything else is coming out in a lot of the residuals are coming out in a filter cake. So it's just a powder that's coming in. And it all has homes, right? Some of it's going in fertilizer, some of it still has precious metals. So working with a local company that will take that material and be able to recover the additional metals that are inside of that. So as I mentioned, we're, Longview, and then we're planning on at least 2 more here in the US. We have the facility, as we can see here in Australia, and then we also have a facility coming online in the UK that is more focused on black mass produced from lithium ion battery processing. And so we also are looking at some different countries as well to add this process where we've had some interest. A lot of it's through that mineral security partnership that we're a part of. And with that, any questions? I told you I'd fly through this.
Students from the audience. One over here. Okay.
I'm curious at the federal level, with the minerals deal and with also coming over here with tariffs, how is any of that affecting?
It's not affecting the plans. It's actually helping moving the plans faster, right? So we're in contact with the government, the administration about, how can we speed our process up? Here's what we're willing to invest in the US in total to help, work directly with some of the departments, such as the Department of Defense, with being able for them to capture their metals from the military equipment because it's very high in gold and copper. So it's actually speeding things up. So we've had great conversations with them. And it's a little unusual for a Republican administration to pushing a lot of this stuff. So it's neat to see because generally the other side is pushing this stuff and they're fighting it. So it's really neat to see kind of how it's all spurring some of it, because I think there's been a lot of things going on where money and grants and, loans and things like that have been cut, but they've been quietly put back in. So that's what's not coming out. So we're really heavily tied to a lot of that stuff to figure it out. Yeah.
I'm curious, I know circuit boards have a lot of dielectric material and there's like polymers and stuff.
Yep.
What happens to all of that? I mean, you didn't really mention, you had gypsum, you had the metals.
Yeah, a lot of that's falling out into that residual piece. Yeah, we have, so when it goes through the double hammer piece, we see a lot of it come out there.
Right.
And then we find a home for that. So it may not necessarily be in the gypsum piece of it, but there is a piece of it that does come out, and we have to send that to a more traditional route to recover those metals because it is heavier and
Oh,
plastic.
it's plastic.
I mean, this is a process that does not like plastic,
Okay.
whereas your traditional smelter uses that as fuel.
Well, yeah, that's what I was wondering, about all of that.
Yeah, it's captured and it's put to a more traditional method. We can't. Wish we could have a
Well, yeah,
solution
you should
for all.
do everything.
Yeah.
Of course.
Maybe hopefully the solution's in this room.
So you mentioned gold by this biomass that grabs on the gold. What about the silver, copper?
Yeah.
How are those things?
Yeah, so it's a similar biomass. That's still in the test phase, right? So they've started doing that in Australia to where they can capture 50% of the silver using the biomass approach, and they're catching a little bit of the palladium right now. By the time this plant gets operational, I'm not going to say we'll be able to capture 99.9% of it, but we'll capture the majority of it at that point. And then it's just going to constantly increase from there.
So some of the challenges, developing new biomass that grab onto different metals.
Exactly.
There's some biomass up there.
I have a question. I know on one of your slides you were talking about like 8.8 million pounds of PCB received each year, 2.2 pounds of copper. Or is that each year? Is it a lifetime facility? Like,
No, that's annual. So yeah, so we'll process about 9 million pounds a year and we'll capture that. Because when you look at, let's just take a desktop computer, for instance, right? That's gonna have about 80 parts per million of gold inside of it. It's probably gonna have 20-ish% copper inside of that circuit board. So that circuit board probably weighs less than a pound. So just kind of doing the math, you can figure out what that would look like. And then silver has generally a little bit higher than everything else. It's just the value is low on it. And then palladium is really, really small amount in a lot of these circuit boards. As you see higher grade circuit boards, gold increases and palladium increases.
Yes.
So I think you had mentioned that this is somewhat of a hot topic.
There's some people.
Yes, so local politics, the location, where?
Address is 2120 East Loop 281. So
Yeah,
right off 281. I think across 281 there's some Sunbelt Rentals or something. But yeah, I think it used to be I forget, some cleaning place before that.
for what?
A cleaning place, I'm not sure exactly. But that's the location.
I think we might be more concerned about security. They got gold and silver and stuff there. I mean, robbers are gonna be one.
Yeah, no, there's a fence.
Or-
There's a fence around it and stuff. So yeah, no, it'll be secure.
Fort Knox here in Longview.
Yeah, right.
Yeah. How many pounds of gold and silver?
11?
Just 1,100 pounds of gold, which multiply that by 32. Well, you got to figure out what the ounces are, but yeah, I mean, gold's 3,200 now, so it's significant.
Yeah.
And then
How much can you keep that on site? How fast you get off site?
well, the goal is
Which truck is it going out?
yeah, right. That's classified.
Oh, good answer, good answer.
That's proprietary. Yeah.
Okay, other question.
From a non-engineer, just people thinking about potential workforce. Reliability engineers, process engineers, are there certain areas that you tend to be looking for?
Yeah, a lot of it's gonna be mechanical and chemical is where it's at because of the equipment we're using and things like that. And just, yeah, all the different, the lab that we have and just trying to understand a lot of, how can we make some of this better? Capture more sort of stuff.
What kind of waste do you see coming out of the plant? Because I live right around that area.
Oh, yeah, no, I mean, there's no waste that's gonna go into, the waste has a home for it, so it's not going to be like coming out of the plant. It's gonna be in a powder form, in a bag. That's gonna be stored inside that will then be trucked out. So there's nothing that's going, the water that I think the wastewater we generate would be put into a holding tank, and then a truck would come and take it out. I don't believe we'll be discharging anything.
Here's why Longview was the location of choice for the first US plant.
Yeah, I mean, cost plays into a lot of it. Texas is a good place to build something like this because getting it from other parts of the country, trucks are always running this direction. So, Dallas is a big hub for that. So getting it to Longview is not a problem at all. So cost is, and then of course we're working with the economic development team. They worked very well with us to, put something together.
So is there gonna be a lot of truck traffic at Drew's neighborhood now? Stuff coming in and going out?
No, well, they should never go into the neighborhood. But yeah, I mean, so yeah, a big large smelter, right, is receiving containerfuls of material, right? We don't have to rely on full truckloads of material. So we're getting smaller lots of material because we're going after the higher grade materials. So there's less of that out there. So it'll be a lot of smaller trucks that will be moving around.
Yeah, and on the bio side, you're talking about some of the organic, crop that's already in soil and stuff like that. Mine some of this, is that grown on site, or is that what happens to the biomass as during the process?
That is a great question. I don't know how to answer. I'm the business development guy, so I'll get an answer for you on that one, because I'm not 100% sure. It is grown, I do know that. It is grown, but I don't know. Eventually, the sponge gets heated up and dissipates into an ash, where we're left with the gold or the silver or the palladium. So it's typically what happens. Yeah, exactly. Exactly.
Palladium is also very expensive. How much of that do you see getting? Because I think the last time I checked, it was as close to gold as you can get.
Not anymore. It's down. It's considerably down. So it's probably in just under $1,000 an ounce. Whereas gold's up to 32. Yeah, it used to be even with gold, which was really nice. But yeah, it depends on the grade of circuit board. Okay, so if you look at, so we're looking at taking motherboards and higher. So anything coming out of a computer and higher. So getting into high grade telecom equipment, things like that. Military gear, things that really have higher gold content. As that gold content increases, the level of palladium will increase. So your motherboard itself will probably have around 10 parts per million of palladium in it. We probably won't see anything higher than 100 ppm of palladium in it. And so it's in comparison to some of the gold, the first of the gold will be a lot lower.
Some of our students want an internship with bio innovation, or Mint Innovation. Try to drop the bottom. Mint Innovation. And do you have any chance like intern in UK or Sydney and that would just be a local internship?
I think for now it would be local. That's not to say that down the road, once we're more established and we can, fund something like that, we could look at that. But I don't think I think initially it'll be, but we have the internships at mint.bio if you are interested. I mean, like I said, I don't know what opportunities exist today. I'm sure as the project management team starts to engage on the build out process, might be nice to have one or two. It'd be a great learning experience.
Are there current internships in Sydney?
We just wrapped up our New Zealand internships over, gosh, their summer's different. So it was their summer. So it was like, it went from like November to January, I believe, was theirs.
Are these paid internships?
They will be paid, yes.
Okay.
Yeah. Yeah. That is good. We are doing, I know our marketing person is, no marketing people here, but we are going to be getting a marketing intern soon that will work with us.
Cool. So look up for more. Want to get a trip to the UK? Hey, you have internships as well.
Yeah, and
I mean, that's the way
the
to
UK
go.
thing is different because it's more for lithium ion black mass. So that's your nickel, your cobalt, nickel, cobalt, lithium, that sort of stuff. So it's a hydro process for that. So you're turning it into the individual salts,
If you
really.
could like internship at the different plants, get a big overview of
Yeah.
the whole operation, and then if you really a good employee, come on board then.
Absolutely.
There you go.
Absolutely.
Plan worked out for you guys. All right.
You're gonna be doing like the research in the US, or is it all overseas? Right now, it looks like a lot of that's based in Australia.
So the R&D team is based in New Zealand. So yeah, so we have a lab there and they're constantly just.
So they're gonna have any
stuff up.
kind of equivalent R&D here?
I would imagine we'll have something at some point. It's not slated to be anytime soon, but I would think we're gonna have to because it's just, trust me, the time.
You don't want all the intellectual property over there. You want some of it coming here.
Yeah, no, absolutely. I mean, I think there will be a need for it. It's just gonna take a little time to see what we truly need once this first plant gets operational.
And it'll be funding the chemical engineering lab in the new engineering building.
Oh, okay.
Got that worked out too.
Yeah.
All right, other questions for our speakers? Yeah. If you want to continue the conversation, we're gonna be having lunch over in the Joyce Room in a few minutes. If you want to join us over there, if you're a student and you don't have a meal plan, we can get you. If you're a visitor, you don't have a meal plan, cover that as well. So let's thank our speaker one more time. Thank you in general for coming to the science seminar this semester. Hope you guys have enjoyed it. If you have, let your team people know. All right, see you all next semester.
Well, thank you, Dr. Moore.
Very good.
That process. So, yeah.
So I went to.
Yeah, so there's no.
It's okay.
We're not having.
Well, I just conversation.
Yeah.
Yeah. I can figure that out.
Anything to the process. Increase